In this problem, we need to find this weight of a steel plate. So we got a steel plate that has got some rounded corners and it's got a hole cut out of it. So we're going to find the weight. It's 3/16 inch thick. We've got some information about the original one and the it's a 2-inch radius. So we've got a 10-inch by 20. I'm sorry, 10 by 14 inch original one. The inner rectangle is 4 by 6 here. That's going to be important stuff. So remember, when we want to find the weight of a steel plate, we're going to use our steel weight chart. And we need to find the area. We actually just need to find the area of the top. So we don't need the lateral area and all that like we did in one of the previous problems there. So let's find this here. We first need to kind of think about where it came from. So, this came from a rectangle. Let me see if I can kind of draw that. It had, it was cut from a rectangle where that didn't have rounded corners, right? And so that rectangle there, let's go like this. That rectangle there, something like that, something like that. Something like that there. So with this rectangle was 10 by 14. So 10 inches this way, 14 inches this way. So we're going to have to break this into some familiar shapes. And there's several ways we could do that, but one nice way is going to be to kind of cut off this rounded bit. So we're going to cut that off. If we think about that, and then we cut this off here like this. If we were to chop that off, then we just have rectangles and rounded pieces. Let me try to draw it flat so it looks a little easier to understand. So here's this piece, roughly. I realize it's not perfect. There's a better rectangle in the middle now. All right. So we're going to cut this piece. This is a hole right here, right? And we're going to cut off these rounded corners. So imagine if we were to just cut right at 2 inches there. Okay, so these are 2 inches here. See what's going on? So we're cutting off these 2-inch circles, or partial circles, because that's the rounded. We know this whole distance here was 10 by 14, right? So the original one was 10 by 14. So this guy right here is 10 inches. And this one right here is 14 inches. Got it? So now we got, what do we have? We have some different shapes. We've got these long, skinny rectangles here, 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 and here. We've got little partial circles here. And we've got a rectangle in the middle minus this rectangle. So we've got to find the area of all these pieces and add or subtract and put them all together. So let's do that. Now, let's start with the middle. It's probably easiest. So when we take 10 inches and we subtract off 2 and subtract off 2, then this piece right here is 8. When we take 14 inches across here and subtract off 2 and 2, then this piece, 14 minus 2 and 2, is 10. Whoops, put it in the wrong spot. This piece is 10. Everything's in inches. So if we want to find the area of this thing right in here, then we need to find this 8 by 10, and we're going to chop out the hole that I kind of have shaded in blue there. All right? So we've got an 8 by 10. So let's start with that. We've got 8 times 10. And we're going to subtract off this hole in the middle. We know the hole is 4 by 6. So this is a 4 by 6 here. So we're going to subtract off a rectangle, 4 times 6. We're not worried about what those numbers are. Just that we have all the pieces of the area. So this is a big rectangle here, big rectangle, minus a little rectangle. And then maybe let's take care of these rectangles in here. These two rectangles are the same here, right? So this rectangle here is a 2 by 8. This rectangle here is also a 2 by 8. Of course, my drawing is not perfect there. But we're going to add in those areas. We've got to account for that. So they're 2 by 8 rectangles, and we have 2 of them. So we could say 2 times 2 by 8. Now that takes care of those green rectangles. Let's add in these, I'll highlight them red rectangles. Let's add those in. Those are 2 by 10, and we have 2 of them. So 2 times 10 is the area of this, 2 times 10 is the area of that, and we have 2 of them. So 2 times 2 by 10. So that I've got all the area accounted for except for these little rounded corners. Now, if we take these rounded corners, and here we have a rounded corner there, and then we've got this rounded corner there, and then we take the other 2 from the other side, and we take this little rounded corner and we put it over here. If we have these 4 rounded corners, again, my drawings are not perfect, kind of freehanding this. All right, let me make that a little better. If we put all those rounded together, we get one full circle, right? So this is one full circle, and we can find the area of that. The radius is 2 inches, right? So we need to add in the circle area of, we don't need each of the 4 pieces, just do the one full circle, pi r squared. So this is the corners. This is the top and bottom. This is the left and right. This is the hole in the middle. All right. And this guy right here is the outside rectangle. All right. So that should cover everything. So now we can go to our calculator and compute all that. I guess I wasn't thinking as I was talking and writing. We kind of need a radius here. The radius of those corners is 2, right? So this will be pi times 2 squared. Now, we can just type this all in just like it is into our calculator. 8 times 10 minus 4 times 6. And if you have a 2-line calculator, which means a calculator that shows all of these things as you type them, then it'll just work it out for you. It knows your order of operations. If you have a 1-line calculator that doesn't show you all this, you have to be a little more careful. You have to type it in the order of operations. All right, you've got to square, then times pi, and write that down. You've got to do this and write it down, so on and so forth. Now, a lot of this we could do mentally. So, if you were going to type this into a 1-line calculator, you shouldn't type all of that. And in fact, even if you were doing a 2-line calculator, probably better just, 8 times 10 is 80. 2 times, or 4 times 6 is 24. This 2 times 2 times 8, that's 4 times 8. 4 times 8 is 32. And then you have 2 times 2 times 10, that's 40. Whoops, plus 40. This other one we don't know, that's pi times 4. Okay, but 2 squared is 4. But yeah, so, usually you probably type this all in there, but it saves some typing. If you do the simple stuff in your head, you won't make typing mistakes. You won't actually type like 8 times 100 or something like that. So, anyways, great. So we've got 140.566. And don't forget that is square inches. Now, How are we going to use that? So we got the area of one plate, all right? 140 square inches. We want to figure out how heavy this plate is, so we're going to need our chart. So looking at our metal weight chart, we got 3/16 of an inch. And so we go look at our steel plate, 3/16 of an inch here, weighs 7.65 pounds per square foot. All right, so we've got 7.65 pounds per square foot. Now, the problem is we have square inches. So we're going to have to do some conversion. Remember doing this at the beginning of the year or first half of the year, hopefully. You'll remember that. So we have 0.55566 square inches. I'll put that over 1. But I need to change that into feet. I need to get rid of square inches. And I need to change it to square feet. And if you look in the back of the book there, 1 square foot is 144 square inches. So we have to divide by 144. So we're going to do, take our 140 number, divide it by 144, see it's almost a whole square foot, and then multiply that result by 7.65. And again, we can just go to our calculator and type this all in there. Okay. So we have our calculator cooperate here. Going to take that number, divide it by 144. And we multiply it by 7.65. So it's almost a whole square foot. See, 144 square inches is a square foot. It's almost a whole square foot. And so this is almost 7.65. 7.47 is more exact. So this is going to be 7.47 pounds. So if you're going to attach this to something where weight is important, we need that number. If we're going to make a whole bunch of these and ship them, we would need that number there. So that's the idea. That's how we find the weight of a plate or a part that is made of several different shapes. So use the areas. Get an area expression. This formula is not in the back of the book, but we know the formula is for rectangles and circles, and we put together all those parts to get our area. Then we can use our steel table to get our weight. So give it a try. Good luck. Work hard.